My name is John Swygert. I am a scientist, a researcher, and an author, and I am the author of the Swygert theory of everything O. Today I want to introduce you to one of the most important ecological insights produced under the Swygert theory of everything. O, a unified explanation for catastrophic tree decline called the Insect Precursor series. This work compiles 4 independent scientific papers, each with its own DOI, into a single predictive framework for understanding how forests across Appalachia, the United States, and ultimately the world are collapsing in ways we have never properly recognized. What looks like sudden death in trees is not sudden at all. What looks like a fungal outbreak is not the true beginning. And what looks like climate stress is usually just the final push on a system that was already doomed long before anyone noticed. Across modern species like lilac, ash, and pine, and even in the historical extinction of the American chestnut, a single hidden pattern emerges. I call it the multi-stage insect-driven botanical immune collapse model, and it reveals the real cause behind almost every rapid tree decline event we see today. The story always begins the same way. Before a tree shows any symptoms at all, often months or years beforehand, precursor insects quietly begin compromising its internal systems. These insects breach the phloem, the xylem, or the bark-level immune defenses long before anyone sees a brown leaf or a wilted branch. Lanternflies, emerald ash borers, pine borers, they each begin this process in secret. Once insects disrupt the tree's internal equilibrium, the second stage begins. The immune system of the tree narrows. It loses its broad-spectrum chemical defenses. Antifungal compounds drop, resin defenses weaken, and the bark environment shifts in ways that favor invaders. At this point, the tree still looks alive, but biochemically it has already been cornered. Only after this invisible deterioration does the third stage arrive, the opportunistic takeover. Fungi, lichens, blue stain molds, and bacterial complexes move into a weakened system, not a healthy one. These secondary organisms are constantly blamed as the cause, but under the AO model, they are simply responding to conditions created by insects. They are the finishers, not the initiators. And finally, after all of this invisible groundwork, the tree appears to die suddenly. A pine turns brown in weeks. An ash sheds its bark in sheets. A lilac rots from the inside out in just a season. But behind every sudden death is a long, hidden timeline the human eye never saw. This exact pattern, proven independently in lilac, ash, and pine, reveals something extraordinary when we apply it to one of the most famous ecological collapses in American history, the extinction of the American chestnut. For a century, we've been told that the American chestnut was wiped out by a single fungus, Cryphonectria parasitica. But the forensic evidence tells a different story. Historical lumber called wormy chestnut is filled with insect galleries, tunnels carved through the wood, long before the blight was ever recorded. Healthy forests do not produce worm-riddled lumber at landscape scale. These galleries are proof that Stage 1 precursor insect assault was already underway across the Appalachian Range. Once this stage is understood, the chestnut collapse becomes predictable. The trees were biochemically weakened and immunologically compromised before the fungus arrived. The blight spread explosively not because it was uniquely powerful, but because the host population had already been primed for failure. This mirrors the exact same cascade seen today in ash, lilac, and pine. After establishing this collapse framework, the next advancement was a breakthrough in detection. If insects always initiate the collapse months before symptoms appear, then the challenge becomes identifying their biochemical signatures before the damage becomes irreversible. This led to the development of Myco-Insect Predictive Ecology, or MIPE. Here's the key insight. Fungi and lichens respond to microbial and chemical shifts caused by precursor insects far earlier than humans can detect. Specific fungal guilds, such as sooty molds, Parmelia lichens, and blue stain fungi, change in abundance, pH reactivity, and spatial patterning 3 to 9 months before visible decline. This means these organisms act as sentinels, signaling early warning long before collapse begins. MIPE provides a low-cost, field-ready detection protocol using pH strips, bark swabs, image documentation, and genetic barcoding. The research behind this system showed more than 90% accuracy in predicting insect-driven collapse months ahead of time. With this tool, arborists and ecologists can shift from reacting to damage to preventing it. The final paper in this series unifies all stages into a single hypothesis, the insect precursor hypothesis. Across every species examined, the same cascade occurs. Insects breach the system. The immune defenses collapse. Opportunistic organisms flood in. The tree fails rapidly. This framework replaces the outdated single cause thinking that has dominated forestry and plant pathology for decades. It also provides concrete, actionable strategies for restoration and ecological intervention. With this model, chestnut restoration programs can integrate early insect shielding, boosting survival rates dramatically. Genomic breeding programs can identify which hybrid lines have lower hypersensitivity responses. Monitoring networks can adopt MIPE protocols to detect risk windows early. This approach doesn't just reinterpret the past, it protects the future. The deeper message here is simple but profound. Forests rarely die from a single cause. They collapse in predictable sequences that have gone unnoticed for over a century. The Swygert theory of everything AO provides the axial framework to finally see these sequences clearly. And once we see them, we can act before collapse becomes inevitable. This unified approach doesn't just explain what happened to the American chestnut, it gives us the tools to prevent similar losses across Appalachia and around the world. My name is John Swygert, and this is the Insect Precursor series under the Swygert theory of everything AO.